Hello everyone, and thanks for joining. While we wait for everyone to get into the webinar, we're going to discuss just a few housekeeping items. First up, on the right-hand side of the screen, there is a menu bar. Within that menu, there is a Questions tab. This opens a window at the bottom of the control panel, which you can see here highlighted in yellow. We'll be here to answer these questions directly back as they come in. Some questions we may hold until the end for the Q&A portion. If you're having trouble with your audio or video at any time during the presentation, please let us know and we will see if there's anything we can help. Next up, on the same menu bar, there is a Handouts section. These files are good reference material that you can download at any point of the presentation. They will be referenced and are great to keep on hand for any future need. Now, if everyone could, just give me a quick note that you can hear and see everything I just talked about, and we'll go ahead and get started. All right, in case anyone has attended a few too many webinars lately, and/or you forgot what you signed up for today, we are going to be discussing 5 important factors when selecting an atomizing spray nozzle. So, who is Xair? We are a manufacturer, seller, and global distributor of engineered point-of-use compressed air products. We are located in Cincinnati, Ohio, where we were founded in 1983. All product designs focus on efficient and safe usage of compressed air and liquids. Our products are commonly used in cleaning, coating, conveying, cooling, spraying, and static elimination processes. In fact, you may be familiar with some of our products like our super air nozzles, vortex tubes, cabinet cooler systems, or industrial vacuums. Just a quick note about myself. My name is Brian Farno. I have been with Xair since 2010 as an application engineer, where I help customers troubleshoot their applications and ultimately help them with a recommendation on which product will be the best solution for their process or manufacturing problem. Prior to being part of Xair, I have 5 years of experience in the CNC metal cutting field, where I trained customers, customized their machines, and serviced their machines. Before that, I received a bachelor's degree in mechanical engineering technology in 2006 from the University of Cincinnati. Go Bearcats! Outside of working with compressed air, spray nozzles, and static eliminators, I tend to stay busy with my family, doing anything and everything we can outdoors and that is hands-on. Now, before we get into the meat of this webinar, I want to define what success looks like for this presentation. If I don't hit on all of these, then please make sure to reach out to me directly and I will personally walk you through any questions. First, by the end of this presentation, attendees will understand the 5 important factors when selecting atomizing spray nozzles. You will also gain a new knowledge of how each type of atomizing spray nozzle works. And lastly, you will have the resources needed to determine the best solution based on the application at hand. Now, with those in place, let's get into the content. Anytime I begin to discuss atomizing spray nozzles, I always have an epic rock song come to mind. Under pressure. Yeah, I'd keep singing, but this microphone won't do it justice, and neither will my ability to sing. I use this to keep in mind that most fluids cannot be compressed like air. They have to be pressurized. With that, the first important factor is whether or not there is a pressurized liquid source. We break atomizing spray nozzles into 2 categories, pressure-fed and siphon or gravity fed. First, we will cover how the liquid can be pressurized. Water, as a utility, is an ideal source when performing a rinsing or cooling application. Using city water is a common practice and is a perfect example of pressurized liquid source. Here in the US, city line pressure to homes and businesses is between 30 and 80 psig. This is ample liquid pressure to utilize with any of the atomizing spray nozzles we are going to learn about today. Industrial facilities may have availability to higher pressures, which can always be regulated down when needed. Utilizing tap water when possible can simplify the installation because there is no need for additional pumps or containers. If something other than water needs to be sprayed, then a liquid pump or pressure pot is going to be the best option. Liquid pumps come in many shapes and sizes. Positive displacement pumps can be found through industrial suppliers, and these move a fixed volume of liquid by the rotation of gears or vanes, the stroke of pistons, plungers, diaphragms, or peristaltic action. That's the squeezing of a flexible tube by a rotating roller. The flow rate of any given positive displacement pump is determined by the cycle speed and is independent of downstream conditions, so a method of controlling discharge pressure is required. This can be done by varying the speed. Many chemical metering pumps, for example, have this feature built in. It's also commonly done with a bypass line fitted with a relief valve set to lift at the required liquid supply pressure. Lastly, pressure pots can also be utilized in areas where a liquid pump is not feasible. These are available in a number of shapes and sizes from industrial suppliers. The key is to ensure that you follow all safety standards in your area and to understand that these will be pressurized by a compressed gas. In the event of an air atomizing nozzle, you can utilize the same source of compressed air feeding the nozzle to energize the pressure pot. Downfalls to a pressure pot are limited capacity. This would have to be refilled. If this is a 24/7 operation with very little downtime, then a pressure pot may not be the most desirable. When a pressurized liquid source is not available, there are still options for generating an atomized liquid spray. Siphon-fed air atomizing spray nozzles are offered in a variety of spray patterns and capacities. They do require compressed air. The compressed air actually performs two purposes in siphon configuration. It draws the liquid up to a 36-inch height, as well as atomizes the liquid to generate the spray. These same nozzles can be installed below a tank or container of liquid in a gravity-fed orientation. A key factor when installing in a gravity feed setup is to ensure that the liquid is shut off. Otherwise, the liquid will simply drain out through the nozzle. More on the best way to handle this later. Siphon-fed air atomizing nozzles offer a simplified installation when a pressurized liquid source is not available because there is no need for a liquid pump or pressure pot. The second important factor is viscosity and knowing the viscosity of your fluid. Next, we will add in more information on the liquid that is being sprayed. In case you are new to spraying a liquid, there are two main categories for atomizing nozzles. Air atomizing, which uses compressed air to atomize the liquid, and liquid atomizing, which only uses a pressurized liquid source. For both of these, the viscosity or thickness of the liquid matters. Viscosity is often measured in centipoise. Now, We aren't going to ask you to get out your calibrated drip ladles in order to help figure out how thick the liquid is. We like to keep it simple wherever possible. Most of the time, this viscosity is going to be given at a certain temperature. This is because liquids tend to get more viscous the colder they get. One of my fond memories from growing up was going to the hollers in Kentucky with family and seeing molasses made. Talk about a full range of viscosity. When boiling the cane, it can flow like hot motor oil and would be rather easy to atomize. Once you get it down to room temp or colder, it barely pours out of the glass. Thick fluids can often be heated through external processes which will lower the viscosity and make atomization easier. The compressed air will have a tendency to begin to cool the liquid during atomization and start the thickening process. That being said, different families of spray nozzles handle viscosity differently. Internal mix air atomizing nozzles are generally kept at 300 centipoise or less for the liquid. This would be no more than a light hydraulic oil or rust inhibitor. External mix are for over 300 centipoise. Think latex paints or coatings, certain types of slurries. And siphon-fed nozzles are all recommended for less than 200 centipoise. Solvents, rinse water, disinfectants. Most manufacturers utilize tap water as their baseline for flow rates, droplet size, and patterns. This is good to know and keep in mind when evaluating a spray nozzle for performance. While these are all general rules of thumb, we will understand a little more on why there are differences for different spray pattern families in just a few minutes. Third, we need to add more information. This time, it is more dependent on the application. What flow rates are we needing to see? In order to properly select the number of atomizing nozzles and size, we need to understand how much liquid we are trying to process. We tie this alongside the area that needs to be covered in order to best fit the number and flow capacity of atomizing nozzles being used. If we need to flow 1 single gallon per hour or less, then utilizing a large half-inch air atomizing spray nozzle and reducing down the liquid flow is not going to be as efficient as just utilizing a 1/8 inch air atomizing nozzle. Now, we have to parallel the spray pattern with the number of nozzles and the volume of the liquid. This is where I don't have an exact formula. It is more of a layout where experience helps aid in the selection process. The key is to look at the target, then use all of the information at hand. When evaluating nozzles, there are performance charts that show the flow rates at various pressures, and those then align with spray pattern dimensions. We may need to interpolate a little bit, or we may need to remember that there are multiple ways, again, to vary the performance slightly from what is published, and that these are guidelines for performance. We'll get more into the spray pattern in a few more slides, so let's stick with the flow rate for now. For air atomizing nozzles, most are readily available in 1/8, 1/4, and 1/2 inch MPT sizes. There are some niche applications that receive some special larger sizes. Those are few and far between. General rules here are 1/8 inch MPT nozzles are ideal for up to 28 gallon per hour of liquid flow per nozzle. 1/4 inch nozzles are good for flow rates up to 66 gallons per hour per nozzle, and 1/2 inch MPT nozzles are available for up to 303 gallons per hour per nozzle. That is a big step up there. That equates to just over 5 gallons per minute. Needless to say, The largest nozzles are not the ones that I'm going to select and recommend for a humidification process. The liquid atomizing nozzles are readily found in 1/8, 1/4, 3/8, and 1/2 inch MPT sizes. The 1/4 inch are generally found up to 2.66 gallons per minute per nozzle. 3/8 are up to 6.48 gallons per minute per nozzle, and 1/2 inch are up to 17.64 gallons per minute per nozzle. The liquid atomizing do generally have a minimum operating pressure range of around 3 psig, which will be the minimum pressure in order to form a spray. A key difference between the nozzles is the area of coverage, saturation of spray, and the droplet size, which will take us to our next factor. The fourth point is droplet size. Droplet size can be a critical factor in certain processes. As we learned earlier, air atomizing spray nozzles utilize a source of compressed air to impact the liquid. This action results in fine atomization of the liquid and can result in very fine droplet sizes. A quality nozzle will keep the droplet size fairly consistent across the spray pattern and be repeatable from one nozzle to the next. Benefits to fine droplet size include even coatings and conservation of liquid. Liquid atomizing nozzles will not have as fine of atomization due to the fact there is not a high velocity stream of compressed air that will impact the liquid. It is a combination of operating pressure of the liquid exiting and orifice design that determines the atomization. In the case of utilizing atomizing spray nozzles for gas or dust mitigation, it is ideal to atomize the liquid into smaller droplets. The key benefit in this scenario is that any time you split a particle in half, you multiply the surface area of the drop by 8 times the original surface area. When trying to absorb gas or particulate, this exponential expansion of surface area can be extremely beneficial. Some liquids and applications even have a droplet size recommendation for best performance. For some paints, the atomized particulate size often yields best results for surface finish when it is between 20 and 40 microns. Disinfectants have been tested from 40 micron up to 207 microns. The better results were on the smaller side of that large spectrum. Keep in mind, the larger size droplets here were from a handheld pump sprayer. To recap, droplet size may be a critical factor within your application. This is why it is a part of the parallel selection process that we go through when looking at atomizing spray nozzles. The fifth and final point brings us to another method of saving liquid and improving the process: shutting it off. Each application comes with a design and layout that may require specific needs to turn the liquid spray on and off. Some may only need to shut the flow off during emergency e-stop conditions of the production line. Others may need to have the liquid on for less than a second in order to only cover a small area with the spray and conserve a costly fluid. The possibilities are endless, and so are the applications. When determining the best means to turn the liquid off, we want to first look at a few points. How many nozzles are there? Where are they located? How are they plumbed? And do I need to positively stop the flow of liquid, or if there is some residual flow, is that going to be acceptable? When it comes to liquid atomizing nozzles, there is only the single inlet. A common method to shut these off would be a standard electromechanical solenoid valve or a simple ball valve. When operating multiple nozzles, or depending on how the plumbing is run to the nozzles, it may be best to place a valve at each. This way, the liquid doesn't drain out of the piping after the supply is shut off. For air atomizing nozzles, the setup can be a little more daunting depending on the number of nozzles, the piping, and the setup. This doesn't have to be the case. With pressure-fed air atomizing nozzles, both the air and liquid supply will need to be shut off. On the liquid side, just like the liquid atomizing nozzles, keeping the valve closest to each individual nozzle will help to reduce the volume of liquid remaining that could potentially come out of the nozzle when not in use. For siphon-fed setups, keeping the valve close to the nozzle will often place a positive lock on the siphon tube, which will retain the liquid near the nozzle in order to reduce the draw time when the spray is activated. Gravity feed situations, again, keeping the valve closest to the nozzle will stop the flow of liquid from draining out of the tank when the nozzle is not needed. Another option on the market, which will reduce the number of valves needed for each nozzle from one on the liquid side and one on the air side, is the no drip option. The no drip air atomizing spray nozzles all have a built-in valve that positively stops the flow of liquid once the compressed air pressure drops below a set point on the nozzle. This doesn't stop at the liquid inlet. Instead, it stops at the inside of the nozzle tip, which means there is no liquid left to drain out of the nozzle. By utilizing compressed air pressure to turn the liquid flow off and on, a single valve can be utilized on the airline. Even in a manifold style setup, where there are numerous spray nozzles across the same compressed air line, placing a solenoid valve will permit a rapid on and off to control the liquid spray. When combining a no drip air atomizing spray nozzle with the speed of a solenoid valve, pulsed spray is possible because the reaction of compressed air is rapid. When spraying a costly fluid or trying to apply smooth coatings, drips or excess liquid can cause rework or waste of liquid, not to mention the overspray. The no drip feature on an air atomizing spray nozzle can eliminate the risks of these happening. Now, let's look at some functional differences in the various spray nozzles. Now armed with an understanding of the 5 important factors, we can begin to look at how various spray nozzles work in order to proceed to the final point in selecting the ideal spray nozzle. I would like to discuss a little deeper on the air atomizing nozzle families and how they actually operate. Remember earlier, we discussed viscosity of the liquid being sprayed will help us determine which spray nozzle is best. Well, this is going to be a good visualization of why. First, the siphon-fed family, which are ideal for thinner liquids that are not pressure-fed. Normally, I would see these with rust inhibitors, waterproofing, maybe even a solvent or thin coating. These nozzles use the compressed air to draw the liquid through the nozzle where they are installed in a gravity or siphon layout. They will generate a vacuum on the liquid port. This is a small amount of force. The air flows into the nozzle and around the exit point of the liquid cap while it is just inside of the air cap, which is what generates the draw. This is where the term siphon fed is generated for the nozzle family name. Once the liquid is drawn to the exit point of the liquid cap, it becomes atomized and the pattern is generated by the shape of the air cap. These nozzles again are ideal for under 200 centipoise liquids. When we look at an internal mix pressure fed nozzle, you can see the liquid and air enter through the body of the nozzle The liquid flows into the center of the body and through a liquid cap, which has a single orifice that determines the maximum flow rate on the liquid size. The standard air atomizing nozzle offers a needle valve which goes into the liquid cap to help aid variability of the spray and adjust the liquid flow. This valve is only affecting the liquid flow. The airflow comes in and passes concentric to the fluid flow into a separate chamber that is created by the air cap. This point is where the air and liquid combine. The impact point is internal of the air cap, which leads to the name internal mix. The air cap shape and opening then forms the atomized spray pattern for the nozzle. Because we are combining the air and liquid internal to the air cap, and the openings on the air caps are small, spraying more viscous liquids does not yield the best results. Adhesives and slurries are also not ideal for internal mix because of this. When the air combines with the liquid, it can start to dry, and slurries with particulate, which may be abrasive, will cause damage to the air cap upon exit over time. As mentioned previously, internal mix spray nozzles are ideal for liquids that possess a viscosity that is less than 300 centipoise. For liquids that hold a higher viscosity, the external mix air atomizing spray nozzles are a good option. As shown in the diagram, the air and liquid still enter the nozzle the same way as the internal mix. The difference is once the liquid enters the center, it actually exits to a point that is just outside of the air cap. The air then leaves the air cap and impacts the liquid stream to both atomize and generate the spray pattern. Because this combination occurs outside of the air cap, the recombination of atomized spray is less likely. This means less chance of the airstream drying or dissipating any of the liquid is less likely. Utilizing the nozzles for more viscous fluids, slurries, or liquids that may dry are ideal for the external mix family of air atomizing spray nozzles. They are ideal for over 300 centipoise. Paints, coatings, even some light baking oils or heated syrups are able to be sprayed with the external mix nozzles. The no drip air atomizing nozzle feature removes the adjustable needle and does remove the variability to either full open or full closed on the liquid flow. The physical sizes readily found of air atomizing spray nozzles are 1/8, 1/4, and 1/2 inch MPT. The 1/8 inch MPT sizes are easy to fit into tight locations that require some precise spray. The variety of spray patterns offer precise coverage where needed. When more area or liquid needed, we can set up to the 1/4 inch version with even more spray patterns. And for the largest coverage and flow rates for air atomizing nozzles, we can move into the 1/2 inch MPT options. Each physical size can have the liquid and air caps interchanged to alter the spray pattern and flow capacities. The common spray patterns for air atomizing nozzles are shown here. Narrow angle round patterns are concentrated flows that keep precision in mind. Narrow angle flat fan patterns are great for products that need a little bit larger area and are potentially being moved down a conveyor. The flat fan spray pattern is going to be great for a sheet coverage and is a wider angle than the narrow. The wide angle round pattern is great for dust mitigation or rinsing of material as it moves down a conveyor. The 90-degree deflected flat fan are great for low clearance applications where a flat fan pattern is needed. Lastly, the 360-degree hollow cone spray pattern gives maximum coverage. up to a 13-foot diameter with the 1/2-inch MPT version. These have been used for dust suppression, rinsing, and even washing the ID of piping. As mentioned earlier, air atomizing nozzles are extremely variable due to the interchangeable liquid and air cap to make different flow capacities in the same physical nozzle size. This is showcased within the performance tables for the nozzle families. The table shown here is for the 1/4 inch external mix, wide angle, flat fan pattern nozzle family. These performance tables contain a lot of information and it can easily become overwhelming. Rather than spin your wheels on this, reach out to one of my team members and let us help. From this table, we can see that the smallest nozzle at the varying liquid and air pressures, while our liquid flow rates will be at full liquid flow. We can then cross-reference those operating pressures with the spray dimensions on the right-hand side of the table to see what kind of coverage area we will have for the nozzle. The last bit of information is the maximum depth of spray. This is the furthest the spray will go horizontally before dropping off. As mentioned, the table always showcases the liquid flow rates with a needle valve at full open. This valve can be adjusted to reduce the liquid flow rate. One reason we show full open is that when the no drip version of the nozzle is used, there is no needle valve. It is either liquid flow off or full open. The air and liquid pressure will still give adjustment in these cases. For the liquid atomizing spray nozzle families, there is no form of compressed air used. This means a pressurized liquid source is all that is needed. While this could be from a pressure pot, they are generally utilized with pumps or city water. The liquid flows into the nozzle through the inlet and then is sent through an orifice which leads to a chamber. The exit of this chamber is through a liquid cap that has precision geometry that will generate a pattern and atomization of the liquid. These spray patterns are generally a heavier spray because the orifice is considerably larger than that of the air atomizing spray nozzles. This makes them ideal for more viscous liquids or slurries. The variability in the liquid atomizing spray nozzles is driven by the nozzle properties and the liquid pressure. The liquid atomizing nozzles are readily found in 1/8, 1/4, 3/8, and 1/2-inch MPT sizes. The flow capacities are determined by the physical nozzle size as well as the liquid cap. 1/8 are great for small parts washing or rinsing in tight spaces. 1/4 inch are the next step and have been utilized in automated rinse applications. To cover more area and flow even higher rates, the 3/8 inch MPT can fit the build. The 1/2 inch are the largest, which offer a tremendous flow rate. These can easily wash out a 55-gallon drum and still maintain a small footprint. Understanding the physical differences in size also helps to better relate the liquid flow capacities that we discussed earlier. The liquid atomizing nozzles are readily found in a full stream pattern which gives a solid cone of atomized spray. To help conserve liquids or leave a centered area free of spray, the hollow stream offers a hollow cone of atomized spray. Similar to the air atomizing nozzles, there are performance tables available for all liquid atomizing nozzles that will show the liquid flow rates at various liquid pressures for each nozzle. The desired flow rates can then be cross-referenced to the far right, where the spray dimensions are listed. Again, this table houses a good amount of information. walking through this is exactly what my team is here to help with. Now that we have gained knowledge of how liquid spray nozzles work, we can begin to see the methods utilized to select the spray nozzles. In the supplemental documents for the webinar, we have included a nozzle selection flowchart. Once we really have a ballpark understanding of what flow rates, target areas, and liquid being sprayed, then we can use this easy to read flowchart to best align an air atomizing nozzle with the application at hand. This chart helps to start at a high level and easily navigate to a single nozzle family. Once we have the correct family of nozzle, we can use the performance tables we just reviewed and select the right nozzle for the application. While I have supplied all of the information in electronic form, you still don't have to do this selection process on your own. The entire application engineering team here at Xair are available to walk through any spray nozzle or compressed air application. With that being said, I believe I have met the 3 goals we set at the beginning of this presentation. You should all now understand the 5 important factors when selecting atomizing spray nozzles. You have gained a new knowledge of how each type of atomizing spray nozzle works. Lastly, you have the resources needed to determine the best solution based on the application at hand. And with that, I would like to now open for the Q&A. One question we had come in is, do you find that most people know the droplet size that they need? Great question. More often than not, they do not. This is where our team here uses our experience alongside your knowledge of what you need and require, and then we work together to get a result that is desired. A second question that came in, what material are spray nozzles readily found in? All of the nozzles discussed and shown in this webinar are readily sourced in 303 stainless steel. One more question that came in, it's tremendous. Can something other than compressed air be used on the air atomizing nozzles? Yes. Compressed nitrogen has also been used and possesses similar properties to compressed air. If you want to use something else, just reach out to one of the team here and we can walk through that with you. Not seeing any further questions. To wrap up, I've mentioned this a few times. Xair is staffed with a team of experts ready to walk alongside you in your application. Feel free to reach out to myself or any engineer for assistance with any questions you may have. Thanks for joining.